but run exists without a receiver as well. Data structures and algorithms. So when we look at coding or programming, a key part of that is designing algorithms. It's about solving problems through computer code. And there are two parts of doing that. There is, generally you need to have some data to be able to actually keep track of where you are, what you are doing. The way that you look at that is called a data structure. How do you store the data related to what you're doing? The algorithm specifies the behavior. And a key part of programming, especially the slightly more advanced one, is algorithms and algorithm design. And yes, this is tricky, but it is an important skill to develop, and it's something you need to practice. That's the only way you get to do it. But an algorithm is say, okay, let's say, okay, it can be as simple as, okay, take all these lines, are they all drawn? Obviously that's a very simple one, and for each the all function you can use the Kotlin default algorithm, or you can loop through every element, and as soon as you find the element that is false, return the function, because then you know that it's not true. You could calculate it all the way through, but that is actually taking more time than you need, because as soon as you find the first element for which the value is not true, you will know that it's not true. But your algorithms always work on data, and the way that is structured also influences the way that your algorithm works. Or your algorithm function, the way your algorithm functions determines how you have to do your data structure, how you have to design your data structure. So looking at your problem and say, okay, how can I structure this? How can I have data for this? Is a very important skill that you hopefully also exercised in the assignment. And it's like where we have these matrices. Okay, what is the best way of doing it? And there's different trade-offs sometimes. And a sparse matrix particular was one of those, where they say, okay, I have this rectangle, but there's some values that are not valid. Okay, how am I dealing with that? I can just add the values that are invalid and skip them somehow, but in a way I just want to, when I want to look at all my lines, I don't want to be bothered about the invalid ones. I want to ignore them. So what do? I create a function that just says, or a structure that allows me to add a function that says they are valid or not. And if they're not valid, I'm ignoring them, and otherwise I'm using them. And because I'm ignoring them, I don't need to initialize them, because their storage space, their storage location exists, but they're not accessible anyway. So a data structure is a conceptual concept of what the data looks like. You normally want to provide an actual implementation. And one of the core aspects that people kind of forget is that many data structures are a collection of types that relate to each other, work together to implement something, rather than a single type. Like in our assignment, the dots and box game and the line and the box classes are all working together to make things work. Same thing like the player, computer player, and human player. They are related. They work together in a sealed class anyway, but they work together to make things work, and they are also, of course, related to the dots and box game, because it works with players, but they are not necessarily part of the same data structure. An algorithm is basically the steps you take, goes hand in hand with your data structure, and creating them is a key skill. One of the elements that I would say that I would recommend everyone, and I can't repeat this enough, is when you are a beginner, and most of you are a beginner, separate designing the algorithm from writing the algorithm. What do I mean? There's at least two ways that you need to think about when you're writing an algorithm. You're first thinking about, okay, what happens? A very good way of doing that is actually to put the computer away, take pen and paper, or make props. A deck of cards can be very helpful if you want to look at how do I sort something. Well, you can make up your ordering of your cards and then just do some sorting. Okay, if I do this, if I do that, how does that work? Does it work correctly, etc.? So that's what you want to do. You might want to write down in pseudocode or in your comments what are the key parts you need to do, and then you write them. Key part there is also, even if you write your code and you have, say, okay, I need a functionality here, that would be something that I would put in a function. It's a bit complex, put it somewhere else so I can, this part can be clear and understandable, and that part can then focus only on that. Don't start immediately when you need, I need this functionality. Oh, I need to write that now. No, you don't need to write that now. You just write the thing with the parameters you think you need. Again, some experience helps with that. And then write that function and then update the thing if you needed to change the parameters. But don't move from all over the place, because you will just not be able to handle the complexity. Key other part of programming, and part of where we want abstraction in programming, is the idea of separating complexity. So how do you create a very complex program? By layering your complexity, by isolating areas of complexity so that you only look at that one at that particular time and something else at a different time. There are some common data structures that you should know about. Very, very common storage. So there's the ArrayList, which is basically, the idea is like you have an array that has some storage locations. It has a size parameter, how many values are actually in use, and when you need to add a value to this variable size list, basically it just adds it to the next free location and updates the size parameter. So yes, getting an element is simply going over a particular index very fast, and that's how that works. And if you have integers, you can even ignore resetting the values that you're not using. If you're using objects, you probably want to set stuff to null if it's been deleted, because because otherwise your garbage collector can't pick up the element yet, because it doesn't know that logically the value is not used, but practically it actually still is. Good way of having a memory leak is having an inaccessible value still exist. And it's accessible to the JVM, obviously. Then there's the structure called a linked list. So basically the idea where you have one element point to the next, point to the next, point to the next. It's a very old computing structure. It actually has some serious drawbacks in a modern CPU. Basically, modern CPUs, they use a lot of prediction to be able to execute a code fast, and they use a lot of caching. Kind of say, okay, if it's close together, I'm likely going to read it close together. Thereby, linked lists can be much, much slower than ArrayList, but you still find them, and there are still cases where they are very useful, or where you need to have multiple things. So you look at an ordered hash set or a linked hash set in JVM that uses a linked list on top of a hash set to maintain order. In which case, yeah, you can't put them in the same thing because that just doesn't work. A hash set is the idea where you have keys and values, but your keys, if your keys are complex, if they're not just integer indices, you need to somehow be able to, and they are not contiguous, you need to be able to somehow have some reasonably compact data structure to store your values, that you can find them based on your key in a fast way. That's what a HashMap does. Basically, it takes a number that you calculate from your key. That number you then use as an index into an array, and then you have a link. And every array is basically kind of starting point of a linked list to actually have the actual data. It could be an order, it could be an array list or something like that, with all the values with that particular key. Okay, there's my mouse. So we have a key here, and then there's all the values or these values. And one thing that you need to realize there is if you have a bad hash function, you got all the elements in one thing and you lose the benefit of a hash table, and it becomes much worse than a regular list. So what is it good at is finding elements based on a particular key. What it's not good at is not so good at is all elements. It can do that. It's not too hard. It does not maintain your order though. And then the final one is binary tree, which is actually a sorted data structure. It automatically sorts, and there's many variants of a binary tree. I could do a whole series of lectures on trees only, but what this binary tree does, it is basically maintains sorted data, so sorted in the natural order of the elements, not in the order in which you added things to the collection. An array list is sorted in the order of adding stuff, not sorted in the order of the elements. So in this case, so a binary tree needs your elements to be sortable. They need to have a natural order. Or a sorting function that provides this capability. But the tree keeps things sorted. So if you need something, okay, I need to keep it, when I use it, I need to have it sorted anyway. Binary tree can be a very efficient way of dealing with that.